All right, so the last type of proof I want to show you with induction is a factoring proof. So these are proofs where it tells you an expression and wants you to prove that a certain number is a factor of it. So you want to think about what a factor means. So if I tell you that 3 is a factor of 12, that means that if I divide 12 by 3, I'll get a number that has no remainder after I divide it, right? 12 divided by 3 is 4, no remainder. Or I can say that a factor is something where I can multiply a whole number to it to get that number. Right? 3 is a factor of 12 because 3 times 4, a whole number, is 12. Whereas like 1.5 is not a factor of 3 because, 2 is not a factor of 3 because to get to 3 from 2, I need to multiply by 1.5. Right? So this is not a factor. But here, that's a factor. So when we say that we want to prove that 3 is a factor of n cubed plus 2n, what we're trying to show is that 3 times some number, which is a whole number, an integer. We can say integer rather than whole number because it could be negative, I guess, should equal this with no remainder. So 3 times an integer should equal n cubed plus 2n. Right, that's the mathy equation that we're trying to get. So then we start off with our base case. And like I said before, in the first video, when you do this, you can do your inductive step first and then do your base case, because these statements are all true. If you didn't know that they were true, then that's why usually we do the base case first, because if the base case isn't true, then there's no point in going on with it. But if it makes more sense in your head logically to do the inductive step first, because these statements are all true, you know the base case is going to work out anyway, you could do it the opposite direction. Anyway, so the base case here would be where n is 1. Right, for n is 1, well, 1 cubed plus 2 times 1, well, that's 3, and a is 1. Right, so that works. 3 times something equals 3. This is what we needed to be. We needed to end up getting 3 times something equals that expression on the right side, where this is an integer value. So inductive hypothesis here is that we suppose that 3 times an integer value is k cubed plus 2k. And this would be where a is an integer. Then we need to show that 3 times that some other whole number value. I'll use b because these numbers aren't the same, right? The thing you're multiplying 3 by. But 3 times a whole number should be k plus 1 cubed plus 2 times k plus 1. And this also needs to be an integer. So now let's try to prove this. Proving these are very similar to what we did before on with the summations. You're just going to have to do a lot of factoring, basically. You want to get k cubed plus 2k out of this. So if I factor out the right side, because there's nothing much I can do on the left side, right? So let's just take the right side. So k plus 1 cubed plus 2 times k plus 1. Well, that equals, I can expand out the cube, which is k cubed plus 3 times k squared plus times 1 plus 3 times k plus times 1 squared plus 1. That's using binomial expansion or Pascal's triangle to do it, to know how to expand out binomials to different powers. The cube looks like this. You don't strictly need to know this. It's a cool thing to know. It shows up on a lot of recreational math stuff. So if you are interested to know how to expand out, supposing you had something like this, to expand that out, you can use something called binomial expansions and Pascal's triangle to do that. So you can look that up on your own. I go on a lot of tangents in these videos, don't I? I'm sorry about that. Anyway, so we expand out the left side, and then we multiply out the right side, 2 times k and 2 times 1. Well, in this, I want to find k cubed plus 2k, which is those two. All right, so I'm going to keep those separate. And then the rest of it is 3k squared plus 3k plus 3. Well, I know that this is already something that multiplies to 3. Right? 3 times a gives me k cubed plus 2k. And then all of this stuff, I can factor a 3 out of it. So now from both these terms, I can factor the 3 out. And so now I can see that 3 times all of this gives me the k plus 1 cubed plus 2 times k. So that means b is this expression. And since we know that a is an integer and k is an integer, this expression is an integer. So from that, we've shown that 3 times b, where b is all of that stuff, is k plus 1 cubed plus 2 times k plus 1. And so we can conclude 3 is a factor of n cubed plus 2n using induction, or by induction. So again, go through this, go through each step, try doing it yourself, justify every step to yourself as you do it, and then if you have questions, you can let me know. At the end of this, I have a few more problems for you to try. These are more challenging type problems. I really like this horse problem. It's a weird induction proof that proves that every horse in the world is the same color, and I want you to tell me what is wrong in that induction that I did. And then there's also this other proof that's more straightforward. It fits the types of proofs we've done, just another proof for you to do. So try these out on your own. If you do have answers to the horse question, you can let me know, and I can talk through it with you. And with that, we are done with all our content for this class this year. So congratulations.